Hello friends. Now today we will discuss some more preliminary concepts in the paper complex analysis, and the preliminary concepts are most preliminary concept is again curves in the complex plane. We have seen curves on the real line, right? A real number system is there. It is like this. This is called real numbers. X-axis, y-axis, any point x comma y, right? If we join the points on real value, then such types of curves are called real curves, isn't it? These are the real curves. So if it is parabola, we will denote it by y equal to something ax square, or what is y equal to x square, or whatever it may be. Parabola. Ellipse, x square upon a square plus y square upon b square equal to 1. It is the curve. Ellipse. All these are real valued functions. But we want to come in now. We want to enter in complex valued functions. Therefore, we'll go for complex curves in the complex plane. Now, all these are real valued functions. That means images are codomain set is real number. Means these are the mappings from R to R, set of real numbers to real numbers, isn't it? Now we want to go for a mapping from set of domain set to complex numbers. Domain set to complex numbers, right? Whose domain set is something and image set is complex number. So you should get image as a complex number. So very basic concept of curve is a continuous curve, or simply a curve, or a path. We can call anything to this curve. Either you call curve, either you call arc, either you call path, all are the same. In a complex plane is a continuous mapping gamma from a closed interval AB, where A is less than B, and A comma B belongs to, that is A and B are real numbers, into C. That is mapping gamma from closed interval AB to complex plane C. For example, if that means gamma of 0 comma 1, you have to find image of 0 comma 1, and it should be in what? Complex. It should be in complex. So mapping from any closed interval to C complex plane is called, and if this mapping is continuous mapping, then it is called continuous curve. The curve in complex plane is also like this, no doubt. All such curves, these are the curves, no problem. Okay, so such types of things, such types of diagrams are the curves. We know that. What type of curve? This is curve, this is curve, this is curve, this is also curve. Okay, all these are the types of curves. What are these? Means it is an image of a point whose image of a point in complex plane. Image of a point in complex plane. Such type of. So what should be the image of closed interval AB to C? Actually, in real valued function, it was not like that. F of x equal to sine x, and here x belongs to what? R. Sine x also belongs to what? R. Real valued function. This is not the curve. Okay. So what is the concept of curve here? It is a mapping whose domain set is closed interval. Not domain set is one point, separate point. It should be a closed interval to complex plane C. If such thing occurs, then this type of diagram, or this type of whatever you know that the term is called continuous curve. So a continuous mapping from closed interval to complex plane is called a continuous curve. It is of this type. Okay. So gamma of closed interval 0 to 1 means gamma of 0 is what? It should be something in complex number. C means what? Your like this. F of this closed interval should be a plus I into b. A plus IB can be represented in ordered pair AB, and what this AB is? It is the point in complex plane. It is the point in complex plane. So gamma of interval means image of interval. It is a point, and set of all such points is nothing but curve. Set of all such points is nothing but curve. So it should be a continuous, a mapping which is continuous. We know that now. What is meant by continuous mapping? We don't want to waste our time in finding continuous mapping. So gamma is a mapping from closed interval to C. Here the points gamma at A and gamma at B are called initial and terminal points of the curve. The image of gamma at initial point is called initial point of the curve, and the image of gamma at terminal point of the interval is called terminal point of the curve C. Okay, respectively. A parametric representation of continuous curve gamma is given by gamma of t is equal to x of t plus I of t. Now, what is meant by this C? C means what? It is a complex number. So if it is a parameter t, then you should get gamma of t is a parameter. Here it should be interval, right? Interval means t belongs to your interval AB. So gamma of image AB, it is like that. A plus IB, it is like that. But if you take t, t belongs to AB, then gamma of t is equal to xt plus IYT, where xt and yt are continuous now real valued functions on AB. T belongs to A comma B. So if I take any parameter t in AB, then gamma of t is equal to xt plus IYT is called parametric representation of continuous curve. Parametric representation of continuous. Here, the interval AB is called parametric interval of gamma, right? Parametric interval of gamma. We'll take some examples on that also. A curve gamma with parametric interval AB such that gamma at A equal to gamma at B is called closed curve. Means what? The curve whose initial point and terminal point coincides is called closed curve. It is like this. Suppose it starts from here and end here. It is closed. Suppose it starts from here and end it again here. It is also closed curve. Suppose it starts from here, 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 and here. Initial and terminal points of this curve are same. Therefore, such types of curves are called closed curve, where initial and terminal point coincide. We don't know what about other. They may be coincide or may not be, but their initial and terminal point should coincide. In this case, we say that the curve is closed. If gamma is 1 to 1, that is for t1, t2 belongs to A comma B with t1 not equal to t2, then gamma at t1 not equal to gamma at t, we call a curve as Jordan arc. Sometimes it is called simple also. Here, this one. Different points have different images. Different points have different images. Okay. Different points have different. Means different points. If I take two different points in this closed interval, then their images should be different. Such types of curves are called Jordan curves or simple curves also. Or simple curves also, 1 to 1. That means what? This is called simple curve, right? Different images. Different points have different images. This is not Jordan curve. Because here, though t1 and t2 are different, parameters are different, but their images are same. Parameters are different, but their images are same at this point. Therefore, it is not a simple curve. Okay. So, it is called Jordan arc. Why we call it as arc? Whose initial and terminal point not coincide. Therefore, it is called arc. For example, gamma t equal to e to the power it, where t belongs to 0 to power. Now you can say that how the curve is parameterized in the xt plus IYT. What about gamma t is equal to e to the power it? This can be written as cos t plus I into yt, cos t plus I into sin t. So cos t is your x of t, which is real valued function, and sin t is your y of t, which is also real valued. So a gamma which can be represented in this form xt plus IYT. So every curve can be parameterized in this way. Gamma of t is equal to xt plus I. That is your e to the power it. We know that. What about xt plus I cos t plus I sin t? If I take its magnitude, then what is it? Square root of cos square t plus sin square t, and it is also equal to always equal to 1. So what this represent? You know that such type of thing represent a circle, part of a circle, unit circle, no doubt, part of a circle, which is unit circle, and t belongs to what here now we have to take 0 to pi. Now t is a parameter which ranges from 0 to pi, like this, right? So suppose that this is a origin 0 and pi means what? We know that this angle is 0, pi by 4, pi by 2, this will be something pi. So we have to find image from t is equal to 0 to t equal to pi, isn't it? 0 to pi at gamma at t, and what we are given? E to the power it. So if I take t is equal to 0, what will be gamma of t? Cos 0 plus I sin 0. Sin 0 is 0. So for t equal to 0, your gamma of t is 1. For t equal to pi by 4, if I take t equal to pi by 4, angle theta is pi by 4. If I take t equal to pi by 4, what about this? Cos of pi by 4 plus I into sin of pi by 4. Cos pi by 4 is what? 1 by root 2. Sin pi by 4 is again 1 upon root 2. So the point is 1 by root 2 comma 1 by root 2. What about that? 1 by root 2 comma 1 by root 2. It is less than 1. It is less than 1. It will be somewhere here. Okay. Similarly, if I take t is equal to 90 degree, that is pi by 2. Cos pi by 2 plus I into sin pi by 2. Right? Cos pi by 2 is 0. I into sin pi by 2 is 1. Means we get I. I means 0 comma 1. So y coordinate is 1. So it will be something here. Right? Similarly, 3 pi by 4 and then pi. So you will get such type of arc, which is a part of circle, having radius r, which is a part of circle. So it is a semicircle. It is a semicircle having radius r. This is the initial point of the curve, and this is the end point or terminal point of the curve. So this is arc which is not intersected anywhere with itself, and therefore such type of curve is called Jordan curve. So here gamma t is a Jordan curve. Since for any t1 t2 with t1 not equal to t2 implies gamma at t1 is not equal to gamma at t2. So different points have different images. Such types of curves are called Jordan curve. So this curve is your Jordan curve. Okay, a Jordan arc or Jordan curve gamma such that gamma at a equal to gamma at b is called Jordan curve. Means if this curve intersect only at end and terminal points, then it is called Jordan curve. So circle, a unit circle is called Jordan curve. It is Jordan arc. No doubt it is a closed curve, but we call it as curve also. So Jordan curve means it is a closed curve which intersect only at end points, not other points with itself. For example, let gamma t equal to e to the power it, where t belongs to 0 pi. So we have taken 0 to 2 pi. 0 to I will take 2 pi. For example, so this will be the circle, initial point 0, then we will get like this. So here for t1 not equal to t2, actually gamma at t1 not equal to gamma at t2, but at end points both are same and whose value is equal to 1. So gamma at 0, 1, gamma at 2 pi is 1. Why gamma at 2 pi is 1 here? E to the power 2 pi. E to the power 2 pi I. And what is it? Cos 2 pi plus I into sin 2 pi. And what is it? Cos 2 pi is 1 plus I into sin 2 pi 0. It is equal to 1. So at initial point only, this curve intersect with each other, and at all other points this is not intersecting with each other. Therefore such types of curves, closed curve, no doubt, called Jordan curve or simple closure. Sometimes we call it as simple curves also. Thus we refer to a point gamma of t as a point on the curve gamma, although gamma of t is an image of mapping gamma in C. So gamma t is called image as well as gamma t is called a point on curve. No, right. Note that two different curves may have the same images. So if we given v1t gamma 1t by this expression 2t into 1 plus I, where t lies between 0 and 1 by 2, and gamma 2t is given by t square 1 plus I, where t lies between 0 and 1. These two curves are distinct curves, that is gamma 1 is different from gamma 2. Curves are different, right? Gamma 1 is different from gamma 2, right? And now we want to find what is the image of gamma 1 under this interval 0 to 1 by 2, and what is the image of gamma 2 for this interval 0 to 1. Now both are here 0 to 1 by 2 and here 0 to 1. We will find the value of gamma 1 at initial point 0. So gamma 1 at 0, put t equal to 0, you will get 0. Gamma 1 at 1 by 2 equal to 2 into 1 by 2 into 1 plus I. You will get only 1 plus I. 1 plus I means which point we get? 1 comma 1. 1 plus I means which point we get? 1 comma 1. So in complex plane or along complex plane, it should be like this. Gamma 1 at 0 equal to 0. Gamma 1 at 0 equal to 0. So where it is the point? 0 comma 0. And gamma 1 at 1 by 2 equal to 1 comma 1. I will take here 1 comma 1. That is 1 plus I. It is like this. Okay. So it is a line from 0 to 1 1. 0 to 1 1. Okay. All we get points now. So if I take gamma 1 at 1 by 4, what will happen? Gamma 1 at 1 by 4. What will be that? Suppose I take this as a 1 by 2, then this becomes 1 by 4. It here somewhere it becomes 1. Okay. This is 0 to 1 by 2. This point is 1 by 2 comma 1. Note, x coordinate is 1 by 2, y coordinate is, sorry, 1 comma 1 is there. Not right. So if I find image of gamma 1 on this interval 0 to 1 by 2, we get a straight line. What about then? We don't want here this one. Okay. Now gamma 1 at 0 is 0. So this point is on the curve. Gamma 1 at 1 by 2 is 1 plus I, that is 1 comma 1. If I find gamma 1 at 1 by 4, what will happen? Gamma 1 at 1 by 4, 2 into 1 upon 4 into 1 plus I. What it should be? It is 2 times 1 plus, sorry, 1 by 2 times 1 plus I. Means what? You will get 1 by 2 comma 1 by 2 somewhere here. 1 by 2 comma 1 by 2. X coordinate is same as y coordinate. So you will get a straight line which joins 0 to what? 1 plus I. 0 to 1 plus I. Means 0 to 1 1. 0 0 to 1 1. The image of this gamma 1t is a straight line from 0 0 to 1 1, or complex number 0 to 1 plus I. It is like that. Okay. So then what about this one? Gamma 2 at t equal to t square 1 plus I. Now at t equal to 0, this is again gamma 2 at 0 equal to 0. So initial point coincide with this one. At any terminal point we will find gamma 2 at 1 equal to again 1 plus I. Now 0 to, in between 0 to 1, if I take gamma 2 at 1 by 2, what this becomes? Gamma 2 at 1 by 2. 1 by 4 into 1 plus I. That means a point 1 by 4 comma 1 by 4, which lies on the line joining 0 0 to 1 1, 0 0 to 1 1. So all the points of gamma 2 images, all the images of gamma 2 of this interval coincide with image of gamma 1 at this interval. So though the two curves are different, their image represents the same straight line which joins 0 to 1 plus I in the complex plane. So though there are different curves, they may represent same curves. They may represent same curves. We can take the one more example. Gamma 3 of t is equal to e to the power it and gamma 4 of t is equal to e to the power 2it for t belongs to 0 to 2 pi, for t belongs to 0 to 2 pi. Both these curves represent same circle. Both these curves represent same circle. What type of circle you will get? This one. Again unit circle. If I take 0, it will get 1. So this is the one, this is the point. 1 means what? 1 is the complex number means what is 1 plus 0 I means 1 comma 0. So here it is 0.1 comma. For pi by 2 you will get 0 comma 1. So here it is. For 3 pi by 2 you will get means pi 2 pi by 2 means pi 3 pi by 2. So you will get this circle, a unit circle, which is gamma 3. Similarly, if I find this is also same circle. And therefore, these two represent two different curves, but they gives same images. So different curves may represent same images. If a curve gamma from closed interval AB to complex plane given by gamma t is equal to xt plus iyt for t belongs to AB, then opposite or reverse curve which is denoted by minus gamma of gamma is defined by minus gamma of t is equal to a plus b minus t for t belongs to, t lies between a to b. That means what? If your curve, this one is gamma in this direction, then only direction will be changed, it will be minus gamma. Initial point becomes terminal point and terminal point becomes initial point. Okay, for example, if I put t is equal to a here, minus gamma at a becomes gamma at b and minus gamma at b becomes gamma at a. All other terms will remain same. So only direction change, that is the opposite or reverse curves, which we know. Thus minus gamma describes the same curves as that of gamma but in the reverse direction with initial and terminal points interchanged. So if gamma t equal to e to the power it, where 0 less than or equal to t less than or equal to pi, 0 less than or equal to t less than or equal to pi. So what about this first curve? First curve is this one. 0 to pi is there. Interval is what? 0 to pi. Therefore, your this curve up to here, this is our gamma. This is our gamma. And what about its opposite? Only this curve. This is the opposite. No doubt. Whose initial point is minus 1 and terminal point is now here. What about minus gamma at t is equal to gamma at pi minus t? Pi minus t. So minus gamma at 0 equal to gamma at what? Pi. Whatever gamma at pi is there, it is minus gamma at 0. And minus gamma at pi becomes gamma at 0. This one. Okay. So what is gamma at pi? Gamma at pi is what? Pi is minus 1. E to the power I pi. E to the power I pi. This is minus 1. And minus gamma at pi is gamma at 0. It is plus 1. So this is the curve whose initial point is minus 1 and terminal point is +1. Or you can write this also, no doubt. So that is the concept of opposite or reverse curves. Okay, this concept is regarding how to add the two curves. How to add the two curves. If gamma 1 and gamma 2 are such that the terminal point of first curve is same as initial point of second curve. Terminal point of first curve, if it is same as initial point of second curve, then their addition can be written as you only add the two curves. For example, suppose this is the first curve C1 and from this we have the second curve C2. Then this whole curve is called C1 plus C2. It's a very simple C1 plus C2. Mathematically, you can say like this, we define gamma 1 star at t by gamma 1 at 2t minus a, gamma 2 star at t by gamma 2 of 2t minus b. This for t belongs to a to a plus b by 2 and t belongs to a plus b by 2 to b. Also defines same curves as gamma 1 star at a equal to gamma gamma 1 star equal to gamma 1 at 2t minus a for t belongs to a to a plus b by 2. Gamma 2 star is defined by gamma 2 at 2t minus b for t belongs to a plus b by 2 to b. T also defines same curves as in this way. 2a minus a means gamma 1 star at a is gamma 1 at a, gamma 1 star at a plus b by 2 is gamma 2 at b, and gamma 2 star at a plus b by 2 is gamma 2 at a, gamma 2 star at b is equal to gamma 2 at b. That means for these two curves, if terminal point is same as initial point, means gamma 1 star at a plus b by 2 is same as gamma 2 star at a plus b by 2. Gamma 1 star at a plus b by 2 is same as gamma 2 star at a plus b by 2. So end point of, right, the end point of first curve should be same as initial point of second curve. End point of first curve must be same as initial point of second curve. If such things hold, okay, both our initial points are same. Now, if gamma 1 and gamma 2 are such that gamma 1 at a equal to gamma 2 at a, gamma 1 at b equal to gamma 2 at a, then we can define a continuous function gamma 1 plus gamma 2, which is the union of two curves on AB by gamma 1 plus gamma 2 equal to V1 star if t belongs to a to a plus b by 2, and it is equal to V2 star if t belongs to a by 2 a plus b by 2 to b. What do you mean by V1 star here? For t belongs to a to a plus b by 2, V1 star gives V1 at 2t minus a. So which is equal to, I will call gamma 1 at 2t minus a. And this is gamma 2 at, what is the second curve? 2t minus b. 2t minus b, where t belongs to a plus b by 2 to b. Thus the formal sum gamma 1 plus gamma 2 is said to represent the sum or union or join of gamma 1 and gamma 2. Hence gamma 1 plus gamma 2 consist of the points of gamma 1 followed by gamma 2. Points of gamma 1 followed by gamma 2. So you have to join the two curves only. Similarly, gamma 1 minus gamma 2 is gamma 1 plus minus gamma 2. Now, for example, if we had these two curves, gamma 1 and gamma 2, if gamma 1 is equal to gamma 1 at t is equal to RT for t belongs to 0 to 1, and gamma 2 is represented by this gamma 2 of t is equal to r into e to the power it, where 0 less than or equal to 2 less than or equal to 3 pi by 2. Then how to add the two curves? First of all, we will see what is the first curve. RT means it is a straight line, right? Gamma 1 t is equal to RT. If R is a real number, t is also number. So what is it? AT, right? It is a straight line. Straight line. Now at t is equal to 0, gamma 1 at t is equal to 0. At t equal to 0, value of gamma 1 is 0, and at t is equal to 1, value of gamma 1 is R. So means what? Gamma 1 is the line joining 0 to R. Line is joining 0 to R. And what is here? R e to the power it is what? It is the circle. R into e to the power it. It is a circle having radius R. Part of a circle having radius R. Now, part of a circle means what? If I put R equal to t equal to 0 now, you will get gamma 2 is R. And if I put, it starts from R now. Starts from R. And if I put t is equal to 3 pi by 2, e to the power I 3 pi by 2. E to the power I 3 pi by 2 means you have to take angle from 3 pi by 2. Means what? This is your second curve. So in diagram, actually this is the first curve. 0 to R. And this is the second curve, gamma 2. Second curve, gamma 2. How to join these two curves? We know that your this total red, this to this and this to this should be your gamma 1 plus gamma 2. Now how to represent it? Gamma 1 plus gamma 2. It is equal to, now see here, it is RT for 0 less than or equal to t less than or equal to 1, and it is R e to the power I into t minus 1 for 1 less than or equal to t less than or equal to 3 pi by 2 plus 1. Why we change this now? If separate gamma t is this one, and here we have taken second thing. First as it is we have taken. Now what about this second curve? What is the union? Gamma 1 plus gamma 2 if your t lies from 1 to 3 pi by 2 plus. If I take t is equal to 1, what will happen here? R into e to the power I into 0, that is R, which is here, which is same as here. R into, if I put t equal to 0, you will get here R. So for 0 replaced by 1. You have to continue it. 0 to 1 and then 1 to t. We have to define gamma 1 plus gamma 2 for this interval, and then from 1 to next. And for next, your last should be R e to the power 3 pi by 2. When it will be R e to the power 3 pi by 2? Only if t is equal to 3 pi by 2 plus 1. So this will be changed. Parameter interval will be changed, and this curve will be slightly changed. And this will be your gamma 1 plus gamma 2. It will be, sorry, this one. This will be gamma 1 plus gamma 2. So curve starts from here to here and then here. This is gamma 1 plus gamma 2. And how you can write it? You can write in this way. RT for 0 to 1 and R e to the power I into t minus 1 from 1 to 3 pi by 2 plus 1. In this way, you can join the two curves. Okay. Then, a curve gamma from closed interval to complex plane can be written equivalently in the form gamma bar is a mapping from 0, 1 to C. That is gamma bar, the only notation of t is equal to gamma of a plus b minus at, t belongs to 0, 1. This curve can be written in this way also, because every such interval can be converted into other interval. Domain set can be converted, for example, like this. Here, what was the domain for gamma 2 of t? 0 to 3 pi by 2. Now, same gamma, this can be written in this way. This curve can be written, and we can take other parameters. T from 1 to 3 pi by 2 plus 1. See here. R e to the power it, where t lies between 0 to 3 pi by 2, is same as R e to the power I into t minus 1 for 1 less than or equal to t less than or equal to 3 pi by 2 plus 1. Means if we change the parameters, you can change the parameters and curves. So one curve can be equivalent to second by changing the parameters. So every interval this parameter can be converted into 0 to something, that is 0 to 1, that we are writing here. So every such interval can be converted by a scale from 0 to 1. So every curve, we can say that for every curve, the domain may be closed interval 0 to 1. Gamma at a plus b minus at, t belongs to 0 to 1. Okay, a polygon gamma with vertices z1, z0, z1 up to zn is parameterized by, polygon means what? Square, triangle. Triangle is a polygon with 3 sides. This square or quadrilateral is a polygon with 4 sides. This is polygonal with 5 sides. This is polygonal with 6 sides, and so on. So a polygon gamma with vertices z0, z1 up to z1. For example, we want to take a polygon gamma with 3 vertices z0, z1, z2. This to this, this to this, this to this. Or only this one, z0, z1, z2, whatever you want. This is also polygon. Having number of sides, a polygon gamma with vertices z0, z1 up to zn is parameterized by gamma k at t is equal to k plus 1 minus t into zk plus t minus k zk plus 1. That is where t belongs to k to k plus 1, where t belongs to k to k plus 1. Okay, so for t belongs to k to k plus 1, k to k plus 1, gamma k of t is equal to k plus 1 minus t into zk plus t minus k into zk, nothing else. Polygon means what? The curve from here to here plus here to here, joining these 2 points. You have to join zk and zk plus 1. You have to join zk and zk plus 1, where t belongs to k plus 1, where 0 k lies between 0 and n minus 1, and gamma is gamma 0 plus gamma 1 plus up to plus gamma n minus 1. What is gamma 0? Here gamma 0 is equal to, means k equal to 0. What you will get? If I put k equal to 0, your gamma 0 becomes, see, 1 minus t into z0 plus t into z1. What is 1 minus t z0 plus t z1? We know that it is line joining z0 to z1. This one. Line joining z0 to z1. Similarly, gamma 1 becomes, by putting k equal to 1, this becomes 2 minus t into z1 plus t minus 1 into z2. It is again a line joining z1 to z2. Then gamma 2 becomes 3 minus t into z2 plus t minus 2 into z3. It is again line joining z2 to z3. And so we get line joining z1 to z2, z0 to z1, z1 to z2, z2 to z3. And if we add all these things, we get the total polygon gamma. Okay. A curve gamma defined on AB is called simple if it does not intersect itself. It is like Jordan. A Jordan arc is simple, no doubt. A Jordan arc is simple. A simple curve with possible expectation gamma at A is equal to gamma at B is allowed. And such type of, if this condition holds, it is called simple closed curve, which is called Jordan curve. This is Jordan arc and this is Jordan curve. Which types of Jordan curves are there? Which types of Jordan curves are there? Circles, ellipses, rectangles, triangles are all simple closed. A simple closed curves, that is, they are all Jordan curves. They are all Jordan curves. Okay, this is that. A curve gamma defined by gamma at t is equal to cos t. where t lies between minus pi to plus pi, is the segment of the line minus 1 to plus 1, transfers twice from minus 1 to plus 1, and then from plus 1 to minus 1. So gamma is a closed curve. But each point of minus 1 to plus 1 is a self-intersection point for the curve, so that it is not simple. Okay, not simple but closed. Not simple but closed. Note that a simple closed curve is Jordan curve. Okay, for example, gamma t equal to cos t. So gamma at minus pi. What is gamma at minus pi? Equal to cos at minus pi, which is same as cos pi, equal to minus 1. And what is gamma at plus pi? It is equal to cos of pi. Cos of pi is same as minus 1. Cos of pi is same as minus 1. Okay. Cos of minus pi is plus 1, while cos of pi is minus 1. Now, what is in between term? Minus pi to plus pi. If I take 0 there, minus pi to plus pi. What about cos 0? Cos at 0 equal to 1. Gamma at 0 equal to cos at 0 equal to 1. Now see the line. Here it is plus 1. Here it is minus 1. So gamma at pi is what? Minus 1. And gamma at pi is also minus 1. So it initial and terminal points same of that curve. Initial and terminal points are same of that curve. Now, cos at 0 is 1. So this is the 1 point. This is for t equal to 0. This is the second point. Now, between minus pi to 0, between minus pi to 0, which angle is there? Minus pi by 2 angle is there. So gamma at minus pi by 2. What it gives? Cos of minus pi by 2. Cos of minus pi by 2 is same as that of cos of pi by 2. And which is equal to cos pi by 2 is what? 0. We get this point. See here carefully. So gamma at pi, this point is gamma at minus pi as well as gamma at pi. This point is gamma at pi by 2 as well as gamma at minus pi by 2. This point is gamma at pi as well as, cos at 0. This point is cos at 0. Means you are moving from this to this and then coming back from this to this. So this curve is the straight line, starts from minus 1, goes to 1 and then come back to minus 1. Then come back to minus 1. Means what? It is actually what? Intersecting each point on the segment minus 1 to plus 1. The curve gamma defined by gamma of t is equal to cos t, where t lies between minus pi to plus pi, is the segment minus 1 to plus 1 closed interval, transfers twice from minus 1 to plus 1. From here to here and then here to here. But then from plus 1 to minus 1, so gamma is a closed curve because initial and terminal point coincide, but each point of minus 1 to 1 is self-intersection point for the curve, so that it is not simple, because there are other points on that curve which intersects itself, and therefore it is not simple, though it looks like a straight line, though it looks like straight line. Okay, we know that, we say that a curve gamma from AB to C is continuously differentiable on closed interval AB, or a curve of class C1 on closed interval AB, or simply a C1 curve on closed interval AB, if a function gamma t given by xt plus I by t is continuously differentiable on AB. What do you mean by continuously differentiable? We know that it should be differentiable, and whatever the derivative is there, it should be continuous. That is a simple concept of continuously differentiable. We know that gamma is a curve, means what? Gamma is a mapping which is given by this xt plus I by t. When we say that this curve is a smooth curve, if this function is differentiable and its derivative is continuous. Differentiable and its derivative is continuous. Okay, so a curve is said to be continuously differentiable, or a curve of class C1, or simply a C1 curve if this function first it is differentiable and then the derivative should be continuous. X dash t and y dash t should be continuous. Continuous means what? Limit of this function at a point must be value of that function. Limit at point must be equal to value at that point. And at end points, your right hand limit at 0 and left hand limit at 0. Left hand limit at b is here, right hand limit at a is there. Both should exist. Both should exist. So both exist and they should be equal. Okay. So a continuously differentiable function is said to be a smooth curve. We call every continuously differentiable function is smooth curve. Every continuously differentiable function is smooth curve. So smooth curve means what? The curve of this type, they are smooth curves. And corner curves means what? These are not smooth curves. Okay. So such types of, if corner points arises there, this is not smooth curve. At this point corner we get. So that we call it as smooth curve. That means what? Because at this point derivative does not, derivative is not continuous here. S dash t and y dash t not continuous. Actually derivative does not exist here. Left hand limit and right hand limit you occur same. At corner point the function is not differentiable. Such corner points. Function is not differentiable. Or you can say that as it is not differentiable, it is not continuous also. So such curves are called smooth curves. So what we have seen the concept of curves, then different types of curves, actually how to represent the curve. Actually this is not in again a syllabus of PMSC part, this is just revision there, and so we are doing it. Revision we are taking it because these curves are useful in the next chapter as well as in whole complex analysis, and therefore we are going for such concept. A continuously differentiable curve is said to be smooth curve. These are some examples of smooth curves. Okay, what examples are there? Gamma t equal to t cube. It's a derivative. What is its derivative? 3t square. Derivative is 3t square. Whether it is continuous? Obviously it is continuous. Obviously it is continuous. Therefore this is a smooth curve. Then t cube plus it square. Derivative is what? 3t square plus 2it. This is also linear. This is also a polynomial function. Therefore it is again continuous. It is again continuous. And not means these intersect, doesn't intersect anywhere. Therefore all these are curve. Jordan arc, this simple closed curve is there because different points have different images, isn't it? Different points have different images. This exists, so therefore it is a Jordan arc of class C1. That means smooth curves are there. Smooth curves are there. This is also smooth curve. This is also, sorry, gamma t equal to 1 minus t z1 plus t into z2, where t belongs to 0 to 1. Gamma t is a line segment, correct, which joins z1 to z2. Here gamma t is continuously differentiable as its a derivative exists, but we can't say about whether it is a Jordan or not. It depends on the values of z1 and z2. What are the values of z1 and z2? If z1 is 0 and z2 is 0, what will happen? What will happen? Gamma t is 0 only. It intersects at one point. So we can't say that whether it's a Jordan curve or not. Or if z1 and z2 are such points, at 0 gamma t is same as well as at 1 gamma t is same. So we can't say whether it is a Jordan arc or not. Only we can say that it is continuously differentiable. It is continuously differentiable. Same thing will happen for here. Gamma z0 plus r e to the power it. This is a circular path whose center is z0 and radius is r. Whose center is z0 and radius is r. Circle is, hence it is a Jordan arc also, as well as continuously differentiable. This is also part of something such mapping. So it can be different. Here it is differentiable function. So continuously differentiable of class C1. 1 minute. Whether it is continuously differentiable or not. Yes, it is Jordan arc, simple, but not continuously differentiable. Why? If I find its a derivative, what will happen? First function as it is into e to the power 2 pi I by t into derivative of 2 pi I by derivative of 2 pi I into 1 minus into 1 by t. So 2 pi I into minus 1 upon 1 by t. Derivative of 1 by t is what? Minus 1 upon t square plus e to the power 2 pi I by t into 2t. What is it? It is equal to t square cancel minus 2 pi I e to the power 2 pi I by t and then plus 2t e to the power 2 pi I by t. Because of this t, we can't say this function is continuous because as t tends to 0, this will goes to infinity. So we can't say it is limit may or may not exist for this and therefore it is not continuous. So it is not a class of C1. So Jordan arc but not a class of C1. Why it is Jordan arc? Because this does not intersect, the points on gamma t does not intersect themselves, okay. So it's a diagram is of this type, okay. It is like that, right? So for this lecture we'll stop here and in the next lecture we'll see some more concepts.